know. Maybe that's just me. You know how it is? Yeah. Okay, here we go. We're going to solve this. All the directions are going to be the same. They're going to be from 0 to 2 pi. And this particular example is going to be an example of a quadratic. And the first period thought that this lesson was easier than the other ones. So maybe you guys think the same. So I got 2 sine squared theta minus 3 sine theta plus 1 is equal to 0. All right, so first of all, do you notice that we are only dealing with sine functions, right? So that's good. We all have one trig function to worry about and deal with. That's pretty sweet. All right. And also notice that this is kind of looking like a quadratic. So we'll just keep the original one. This is kind of looking like a quadratic. So at this point, we're going to say this. We're going to say, let's let x equal the sine of theta. Okay, we're going to make this little distinction here. Now, why would we do that? Because then we get something that looks like this. 2x squared minus 3x plus 1 equals 0. Oh, that's pretty sweet, right? That's a quadratic. And we're very good at solving quadratics, aren't we? Okay, so what are the 3 ways we can solve a quadratic? We can graph it, we can complete the square, we can factor it, and we can, well, the quadratic formula, right, the big wrench. So, let's try and factor this thing. The big wrench. So, how do you factor a quadratic? Ooh, who remembers how to do that? Yeah, so we're going to have 2x in the front, good. 1 in the back, right? And let's see here, it has to add to a negative 3. So we'll probably have to go 1 and x there. And then minus for both, is that right? Let's see here, 2x times negative 1 is negative x, minus 1 is negative 3x. That's what the middle term is. And then negative 1 times negative 1 is a positive 1. Good, we're doing good. Okay, then also recall from algebra we have 2 numbers that are multiplied together. We have this number and this number. 2 numbers are being multiplied together that equals 0. What can we use? What's that thing called again? 0 product property. Very good. Nicely done. So we can solve each one of these for x, right? We can say, all right, x is going to be positive 1/2, or x is going to be 1. Want to just solve each one of those little binomials for x? Everyone cool with that part? Okay, now look back up into your little square here. What was x again? Sine of theta. Oh, so now we automatically have sine of theta is 1/2. And over here we have sine of theta is 1. Okay, so we're seeing how this works. So let's look on the bite size here. And what angle do we need to be at for the sine of theta to be at 1/2? I can see 2 of them. Can anybody find one of them? Pi over 6. I got you. Theta is at pi over 6. I would agree. And then where else? 5 pi over 6. I would agree. And then how about when the sine of theta is equal to 1? We have theta is equal to pi over 2. So therefore, our solution set is down here in the blue box. All right, what do you guys think? That's not so bad, right? It's not so bad. I would agree with you. That's not terrible, right? And the whole idea is letting that trick in the somewhere in the middle there, like assigning x be one of your trig variables, and then it becomes easier for you. Okay, let's do 2. Let's do this one. Let's do 3 cosine theta. 3 cosine theta plus 3 equal to 2 sine squared theta. All right, what's different about this one than the last one? Okay, it doesn't equal 0. Good, and what else did you say? And there's two different trig identities. We have a cosine here, and we have a sine squared over there. All right, so look in your toolkit. Is there a way that we could change one of them to look like the other? Anybody see it? Change sine squared to what? 1 minus cosine squared. Very nice. So we'll say 3 cosine theta plus 3 is equal to 2 times 1 minus cosine squared theta. Now I have my new row contains only cosines. And that's good news for us. We want that to be the same, right? It only contains cosines. Then I'm going to do some distributing and combining like terms. So I'm going to have, on the left-hand side, 3 cosine theta plus 3 equals 2 minus 2 cosine squared theta. Ian, you still with me? Yep. All right. So I'm going to move everything to one side. So this is going to become 2 cosine squared theta plus 3 cosine theta. And then 3 minus 2 is plus 1 equals 0. Okay, everybody, what should I let x be? You got it. Let x be cosine theta. So then I would have 2x squared plus 3x plus 1 equals 0. Okay, this is easy. So we're going to factor this again. What's that? I think there's a minus sign, right? So we're going to have a 2x, we're going to have an x, we're going to have a 1 and a 1, and everything is positive, right? Again, we're going to use the zero product property that says that two binomials multiplied together equals 0. One of them's got to be 0. So that means x is negative 1/2 or x is negative 1 when I solve each little individual binomial for 0. Was that, Omar? We're good? All right, so what was x again? Look back there in your box. Cosine theta. So we have cosine theta is negative 1/2. Or we've got cosine theta is equal to negative 1. All right, let's consult the unit circle. When is the cosine of theta equal to negative 1? Half. Yeah, it's equal to 2 pi over 3 and 4 pi over 3. Nicely done. And how about when's cosine theta equal to a negative 1? Ah, you got it. So our solution. Okay, so try this one on your own. You might want to consult the graphing calculator at some point in the strategy. We'll give you about 4 minutes to sort of think about this one. Please talk to your neighbor, get some input from them, work with each other, and then we will talk about this one. Is an interesting answer. So Ian's or Ivan says to change this to 1 minus sine squared theta. Plus sine theta equals 2. Is that a good step? Yep. Okay, then what'd you do?
Well, then I brought everything to the left side.
So 1 minus sine squared theta plus sine theta minus 2 equals 0? Yep. Then what?
Well, then you can combine like terms with 1 and the negative 2.
Alright, so I'm with you. 1 minus 2 is negative 1, right? Equals 0. Alright, then what? Okay, so then you said sine squared theta minus sine theta plus 1 equals 0. Is that what you did? Yep. Okay, fair enough.
And then I said let x equal sine.
Let x equal sine. That's a good call.
So x squared minus x plus 1 equals 0.
Okay, let's stop right there. Who got there? Who got this far? Who got x squared minus x plus 1 equals 0? Or something similar to that, depending on maybe you didn't multiply by the negative 1. All right, nicely done. The room is like 80%. Hands are up. Good. Okay, so from here, what are your options? What are our options here once we get to this point? Quadratic formula, factoring, complete the square, right? And you chose to complete the square. That's cool. So what'd you do?
So I subtracted 1 from both sides.
So you'd like magic number there equals negative 1 plus something over there, right?
Right.
Okay, good. What'd you put inside there?
So then I put the magic number is 1/4.
Yeah, 1/4. I agree. 1/4. Because it's half of a half, right?
So,
or sorry, it's a half squared. Because this is 1 divided by 2 quantity squared. Half of the b value squared. Yeah, which is half of a half. All right, yeah, still with you.
So then you can change that to the quantity x minus 1/2 squared.
Yeah, very good. X minus 1/2 all squared, yeah, equals negative 3/4. Then what do you do?
Then you take the square root of both sides.
And then what happens?
So then you get an imaginary number.
Yeah, look at this business over here. Is this possible? No, that's bad, right? That is no real solution. That's that. So he comes up with no real solution. All right, anybody come up with anything different? Anybody actually get an answer for this? Okay. All right, let's do this. Let's go to our graphing calculators. Let's turn those things on. Pull those things up. And let's go to y equals. And what was the original problem that we plugged in? Cosine squared x. So we're going to go cosine x quantity squared. Okay, then what? Plus sine. Where am I here? sine x, and then on the other side I want to put a negative 2, right? When does that equal to negative 2? When does that line cross out of negative 2? So let's go to our window. Let's make sure your window goes from, oh, what mode am I in? Radian, yeah, window. Okay, window goes from 0 to 2 pi. So mine's a little messed up here. I'm going to go by increments of pi over 2. My lowest y value, I want to be, I have to go down to at least, well, I guess 0. So we'll just go negative 1, and then we'll go up to, I have to go at least to 2. Wait a minute, is it 2 or is it negative 2, you guys? Isn't it positive 2? Isn't this a positive 2? That's a positive 2. All right, thanks. That's cool. Back to Windows. So now I want to go down to negative 1. I got to go up to, let's go to 3, huh? So I can at least see the 2, right, inside the band there. All right, let's hit graph. Look at this funky thing. Wow. All right. So does the line y equals 2 ever touch the sine or the cosine squared theta plus sine theta? No, it never touches it, right? So that also, the picture confirms our answer of no real solution. So this one, I would agree with you, definitely has no real solution. So that is a possible answer for us sometimes, okay? All right, I got one more for you guys. Can you hang in there? All right, one more for you. We're going to do this one here. We're going to do sine of theta multiplied by the cosine of theta equal to negative 1/2. All right, sine of theta multiplied by cosine theta equals negative 1/2. All right. Well, right off the bat, right, we noticed that sine and cosine, neither one of those is squared, and we have two different ones. And usually the train of thought is to get them to be 1, right? Well, in this case, we're going to try and use some identity to help us out. So you look at your toolkit. Is there anywhere on the toolkit where sine and cosine are being multiplied together? Oh, yeah, right? Because we know over here, we know that the sine of 2 theta equals 2 sine theta cosine theta, right? Yeah, exactly. So all we have is this part, right? We have the sine theta times the cosine theta. We have that part. So what part are we missing? A 2. So let's multiply both sides of this thing by 2. So I get 2 sine theta cosine theta is equal to negative 1. Okay, great. Now how much is 2 sine theta cosine theta? What does that equal? There you go. That's just the sine of 2 theta, right? Equals negative 1. And then we're back into what we're doing yesterday. Well, we know sine of theta is equal to negative 1 when theta is equal to what value will give you a sine of negative 1? What angle? 3 pi over 2. There you go. 3 pi over 2 plus 2 pi k. All right. So we go back and we say, okay, well, we've got the argument of 2 theta is equal to 3 pi over 2 plus 2 pi k, or k is an integer, right? All right, so we're going to solve this thing for theta, so we're going to divide by 2, divided by 2, divided by 2. So theta must be 3 pi over 4 plus pi k. Great. Well, how many solutions are we looking for? We don't even know yet. So let's go ahead and graph it, huh? Let's do sine theta cosine theta equals negative 1/2. So y equals, let's just go sine x times cosine x. And let's delete everything else. And let's go down. Let's make this a negative 1/2. Negative 1/2. All right, let's hit graph. So there's my trig phone. Okay, well, how many solutions are we looking for, guys? We're looking for 2. Good. Thank you, calculator. Appreciate that very much. So do we have one of them? Yeah, we sure do, right? We have this one right here, 3 pi over 4. So that's a solution. So I got 3 pi over 4. And I need another one, right? And we found that when k was 0. So let's let k equal 1. And let's see what we get. We would get theta equals 3 pi over 4 plus 4 pi over 4 when I make a fancy 1, which gives me a grand total of 7 pi over 4. And there are my 2 angles for which the theta equals negative 1/2. All right? What do you guys think about that so far? Easy?